All right. In this next section, we're going to continue our discussion of factoring, and we're going to talk about a whole different bunch of ways you can factor things and a whole bunch of different things that can be factored. But before that, I need to introduce a couple of important terms that you will want to remember and really take to heart, because these are going to show up all over the place, and so you're going to need to know what these are. I've mentioned coefficient before and briefly explained what it was in a previous video, but now I feel like it's appropriate that we need a formal definition just to know what we're looking at going forward. So a coefficient has my definition of it as a numeric and constant quantity being multiplied by a variable and is visually placed in front of said variable. And so with an example, what that basically means is if you have 4x, then 4 is the coefficient of x. It is the number being multiplied by a variable that sits to the left of the variable in front of it. And with that, as long as we know what a coefficient is, we can introduce our next term, which is a leading coefficient. Now, a leading coefficient is defined as a coefficient that is being multiplied by the variable with the highest power in an algebraic expression. So let's say given this trinomial, we have 3x squared plus 2x plus 1. Now, the x with the highest power is right here, the highest power being 2. This is a power of 2, this is a power of 1. There's no x right here, so the x with the highest power is this one over here. So by that logic, the leading coefficient is 3. So 3 is said to be the leading coefficient. That means that it is the constant that is multiplied by the variable with the highest power. Okay. So now that we know these two terms and we can use these in our, notebook of math lingo, we can move forward with what this video is really about. Now, this section is, or at least this video, is going to be a specific subsection of factoring. It is just a specific case of factoring. And so I want to point that out right now. We're going to look at factoring trinomials with a leading coefficient of 1. And so really quick, let's break down that title. Trinomials. Tri refers to 3, nomial refers to term. So we're factoring something that has 3 terms, like this above, with a LC's leading coefficient of 1. So we are not factoring this right now. This has a leading coefficient of 3. We are looking at something like this, a leading coefficient of 1. And another side note, I know I've mentioned this a few times, but if you have a variable with nothing in front, that means there's a 1 there. But since anything multiplied by 1 is just that thing, writing 1 is redundant, and we don't write that in math, usually ever. You can if you want to make you feel comfortable, but just know that if there's just a variable, there's a 1 there. It's one of those variables. All right, now we want to go from something like this, given a product, which I know we've gone over this terminology in a previous video, of, let's say, x squared plus 5x plus 6, just an example, to this. We want to factor it so we end up with its factors. And again, I know I've gone over this in a previous video. Factors are things that are multiplied together to give you a product. So product is, the term used for multiplication, but when you do the reverse and you take something that's been multiplied and you split it up into the two things that have been multiplied to get it, these are called factors. So this being factored would give you this. And if you haven't been exposed to something called foiling, a technique that's used to multiply these two things, I have a video up on it. It's in the, should be at the top of the, playlist called, I think it's just called How to Foil. But just to prove it to you really quick that these are the correct factors, we would foil it. We go first, x squared, inner, 3x plus 3x, outer, plus 2x, and then plus 6 last, which these two things can be added together, so x squared plus 5x plus 6. Okay, so just really quick proving to you that this indeed is the factors of this. If you multiply these together, you do get this product. But how do we go from here to here? I mean, I have the answer, and I know how to, obviously, but how can I tell you guys to? And I want to do that by giving you a general case. And so what that means is I want to start with something very broad and generalized, and then you can use that with any numbers you're given. So as long as I give you the general case, you can use it in any specific case with any given numbers. So let's do that really quick. Say you have x plus m times x plus n, where m and n are constants, which just means they're numbers. So just, you could insert any number here, it doesn't matter, but we're just leaving it vague, m and n. They're not variables. I'm going to point that out right now. They're not necessarily variables for our case because we're treating them as constants. But just to make this generalized, I mean, they kind of are, they kind of aren't, but regardless. If I were to FOIL this, I would do, again, first, x times x is x squared, and then outer, first outer, I don't know if I did that right, plus nx, inner, plus mx, and then last, plus m times n. And so when I FOIL this, I get x squared plus nx plus mx plus mn. And just like up here when I had 2x or 3x plus 2x, you can add those together since they have the same variable, the same power. So just like right here, we don't know what m and n are as actual numbers, but we can still factor out an x from them, like we did in one of our previous factoring videos in section 6.1. We would get x squared plus x times m plus n plus the product m times n. And so what this means basically is you would add these two. If these were regular numbers, you would just add them and you get one term here. That's the same thing. I would add them and I would multiply an x by that. So this is just saying, simplifying without actually having numbers here. And so what this shows is that no matter what, whenever you have something in the form x plus m times x, and this could be minus, plus, it doesn't matter. The signs don't matter. This could be negative, negative, positive, negative. It does not matter. Whenever you have two binomials multiply by each other, and both x's are just x, they don't have any number in front of them, so the coefficients are 1, then you will always end up with something of the form like this. So that's very powerful, because if we know that whenever we multiply something of this form, we will always end up with something like this, then given something in this form, we can always come back to here, and I'll show you how. This is kind of showing a different factoring method, but regardless, this is just, in general, this is a subsection. Again, I want to point out, you can only do this when you're given a product with 1 as the x squared term, as the leading coefficient. So let's do an example. And with that example, since we know the answers to this, let's just use this. Let's say, given x squared plus 5x plus 6, find the factors of this trinomial. So in this example, we're given a product, or just a trinomial, and we want to factor it. We want to find the factors of this. But I also know that this should be in the same form as this. So assuming that this is factorable and has factors, this will be in the same form as this, because we're assuming that the factors are in this form. So with that, we have a 1 right here and a 1 right here. So the coefficient of x squared should be 1 no matter what. So that's fine, we can leave that alone. However, since there's a 5 right here, and we know that in the general case, there's always an m plus n in front of this x, then we know that m plus n should equal 5. And this might be kind of a leap in logic for you, but if these are in the exact same form, then their coefficient should be equal, right? So if we have x squared plus something x plus a constant and a plus a constant, then we can set those coefficients equal to each other, because this should always take the form of, these should be in the same form. So there should always be two numbers that add to this term, and there should always be two numbers, m and n, that will multiply to this term. And so what I've given you now is a set of formulas that you can use to solve for the factors. Now, the formal question, I'll write it is, what two numbers add to 5 and also multiply to get 6. So the same numbers. And the way we can go about doing this is, let's look at the factors of 6. 6 has factors of 1 and 6, 2 and 3, and that's it. So now we can check these numbers. Well, we know that one of these two has to be m and n because these are all the factors of 6. So these are the only numbers that can multiply to get 6. So do 1 and 6 add to 5? No, they add to 7. Do 2 and 3 add to 5? Yes, they do. So since we found two numbers, 2 and 3, that when added give us 5 and multiplied give us 6, we're done. We have our factors, because by that logic, the generalized form tells us that if we have m and n, then we will have factors x plus m and x plus n. And we have found m and n. So our factors are x plus 2 and x plus 3. And obviously you can see I wrote them backwards, but there's the same factors that we had in our initial example. So as long as you have a trinomial term that has a leading coefficient of 1, because again, this will only work with a leading coefficient of 1. But if you have a leading coefficient of 1, all you need to do is look at whatever is attached to the x and whatever is multiplied at the, or whatever is just the constant term at the end, and find two numbers that will add to this term and multiply this term, and it will always work. And so we can do another example to kind of solidify that. Now, I'm going to say we have, let me do it in my head real quick, x squared plus 9x plus 20. So already, right off the bat, we already got all the logic out of the way from last time. So now we know that we have a leading coefficient of 1. So say a bulleted list, LC of 1, check, and that's literally all the checks you have to make. Now, find two numbers that add to 9 and two numbers, the same two numbers that multiply to 20. So add to this number, multiply to this number. Now, to do that, let's break this down and find the factors of 20, because that's the easiest way to find two numbers that multiply to get 20 is finding its factors. So as always, 1 and 20 are a factor, 2 and 10 are factors, 3 does not divide by 20, 4 and 5, nothing with 6, nothing with 7, nothing with 8, nothing with 9, and then we're back to 10. So we have three sets of factors. 1 and 20 multiply to 20, but do they add to 9? No. 2 and 10 multiply to 20, but can they add to 9? No, they add to 12. 4 and 5 multiply to 20, and when you add 4 and 5, you get 9. So our numbers are 4 and 5. They are two numbers that add to 20, or sorry, multiply to 20 and add to 9. So that's it. You have your factors, x plus 4 and x plus 5. Done. And so you can always check this by foiling it back out, but that is the general method. When you have a leading coefficient, again, a leading coefficient of 1, there has to be a 1 right here, but when you have a leading coefficient of 1, all you need to do is find two numbers that add to this middle coefficient and multiply to this last number. And once you find those, you're done. You have your factors. They come out in this form. Now I'm going to take a second and write the most generalized form of this that I can. So we know that we'll always have something of the form x squared plus x times n plus m times n when you have factors of x plus m times x plus n. Say when. However, you're going to be given, a trinomial in the form x squared plus bx plus c. Now, again, b and c are also just some numbers, just like m and n are. So, again, I know I've kind of laid it out for you a couple times, but the general formula to go about this is if you're given a trinomial in this form with b and c as some numbers, then you want to find two numbers, m plus n, so m and n are just two random numbers that you're going to find, that will add to b, and those same two numbers that multiply to c. And once you find those numbers, your factors will take the form x plus m, x plus n. So that is for the specific case when you have a leading coefficient of 1. Again, mind you, I wrote nothing here because it has to be a 1. But when you have a trinomial, specifically a 3-term polynomial with 1 as leading coefficient, then your automatic, set of process you can go through is find two numbers that add to the middle coefficient and two numbers that multiply to this constant or this constant. Okay, and that is the through and through way. You can do that over and over again, and I would always recommend finding the factors of whatever this number is, c, and then using them going forward. But if you have any questions or if that was confusing, leave a comment, I'll answer it. And if you thought this was helpful, you should like and subscribe.